Today we're going to start a new unit. This new unit is going to be an introduction into probability, but before we get into probability, we're going to first start off by talking about sets. Now, sets or set theory is a kind of general topic that can be applied to different areas of math, one of which is probability. So first let's talk about what a set is. So a set is a well-defined collection of objects in which it is possible to determine if a given object is included in the collection. So by well-defined, it simply means that we know exactly what objects are within that set. Now, in terms of notation, we use what we call set braces. They're kind of the curly brackets enclosing all the elements in the set. Now, what is an element? Well, an element is any object within a set. And in set notation, we use this notation here. It kind of looks like an E, but it really is a symbol that indicates that an element is within a set. Now, the empty set is the set with no elements, and it's written symbolically with what looks like an O with a slash through it. So this means that the set has no elements within it. We say that two sets are equal if they contain the same elements. So when we're talking about sets, order doesn't matter. So if you have the same group of objects, no more, no less, as a different set that has the same exact objects, even if you rearrange them, you would say that those two sets are equal to each other. Now, subsets are sets whose elements are all contained within another set. In terms of notation, we saw that we used the notation that kind of looked like an E to say that a certain object is an element within a set. But if you have an entire subset inside of another set, we would use this notation here. So if A is a subset of B, this is the notation. So it kind of looks like that E without the middle line, and instead we have a line below it. So that means A is a subset of B. Now, if A is what we call a proper subset of B, or in other words, A does not equal B, so it is only a portion of the elements in B, we call it a proper subset, and you can go ahead and leave out the little mark on the bottom. That means a subset could simply be equal to the larger set, but a proper subset is not equal to that larger set. It must be just some portion of the elements in B. Now, a couple properties of subsets. So first, the empty set is a subset of any set. So it is impossible to find an element of the empty set that is not an element of the set A. So we would say the empty set is a subset of any set. And then any set A is going to be a subset of itself. So because every element that's in A is also an element in A, so we can say that A is a subset of itself. Okay, so the empty set is a subset of any set, and the set is always going to be a subset of itself. All right, take a look at example 1. We have 4 sets that are defined for us here. It says, decide whether the following statements are true or false. Okay, the first one here. So this reads that A is a subset of C. So we want to see whether or not all the elements that are in set A are all contained in set C. So we can go ahead and take a look. So 3, 4, 5, and 6. Yes, those are all also in C, 3, 4, 5, and 6. So this is true. All the elements of A are in C. All right, look at the next one. This reads that 2 is an element of A. You look at your set A, and we do not see 2 as an element. So we would say this is false. 2 is not an element in A. All right, the next statement, A is not equal to D. So look at the elements of A and look at the elements of D and see if they are exactly the same or not. So A is 3, 4, 5, 6. D is 6, 4, 5, and 3. They're the same numbers, and although they are in a different order, that is okay. They have the same exact objects, the same exact elements within each set. So we would say that A and D are equal to each other. They are the same. So this is false. Okay, and then the last one here, this would read that B is not a proper subset of C. So look at B, we have 1, 2, 3, 4, 5, and C we have 2, 3, 4, 5, 6, 7, 8. That's true, because we have 1 that's in B, but that's not in C. So because 1 is an element of B and not in C, we can say that B is not a proper subset of C. All right, take a look at example 2. We're going to list all the possible subsets for each set. So basically, we want to come up with all the different ways that you can come up with a subset, so a portion of each set. Now, remember that the empty set is a subset, and any set is a subset of itself. So those two are always going to be true. So the empty set, I'm going to write that. And now let's go up to 1, so subsets with just one element in them. So that would be just 7, that's one subset, or just 8, that's another subset. And then we also know that we said that any set is a subset of itself. So 7, 8 is also going to be a subset. So it looks like we have 4 of them here. And that's it. Now let's try with the next one. This one has 3 elements. Let's again start off with the empty set, and then we'll go up. So all sets that have just one element that are subsets of this, that would be just A, just B, just C. Now let's go up to 2. So taking 2 elements to create a subset of this set here. So that would be A and B. We can say A and C, B and C. And I think that's it for 2. And then remember that any set is a subset of itself. So lastly, we have A, B, and C. So it looks like here we have 8 subsets. Now, how do we come up with the number of subsets that a set has? So not how do we come up with the subsets, we just did that, but how do you know how many there are going to be? Well, if you look at example 2 here that we just did, in the first one we had 2 elements within that set, and we came up with 4 subsets. In the second one, there were 3 elements in the set, and we came up with 8 subsets. So we came up with this. A set with k distinct elements has 2 to the k subsets. So if you look back at the examples that we just did, we saw that when there were 2 elements, we had 2 squared subsets, right? That's 4 subsets. When we had 3 elements, we had 2 to the 3rd number of subsets. That's 8 subsets. So we can see how that applied to our example there. Okay, so for the next ones, rather than writing out the subsets, we just want to know how many subsets there are. So in this first one, we see there are 5 elements in that set. So that means we're going to have 2 to the 5th number of subsets. So that would be 32 subsets altogether. Looking at the next one, we have Sunday all through Saturday. So it looks like that's going to be 7 elements in this set. So how many subsets are there? 2 to the 7th, which is 128 subsets. Now the last one, this one's a tricky one. This was an empty set. Remember that the empty set has no elements within that. Well, how many subsets does it have? Well, if there are no elements, we have 2 to the 0 subsets. So that's our answer, 1 subset. What is that 1 subset? Well, the empty set is always a subset. And we know that for each set, we can always count itself as a subset. So in both cases, the empty set, which happens to also be itself, is the subset.